So thank you again for coming. This is the third seminar for the Minnesota Robotics Institute. It's my distinct pleasure to present to you one of the most exciting speakers that we have had, and he's going to tell you Nick Fragale, and he's going to tell you his story and the story of his company. And also the ups and downs, the possibilities, the opportunities, and the whole experience. So without further ado, make sure, I'm pretty sure you're going to have a lot of questions at the end. So Nick, thank you for coming.
Thanks, Professor. So do I have a full hour? Is that right?
You can have full hour, you can have 45 minutes, and then 15 minutes questions.
I'll make sure to leave plenty of room, time for questions.
From the other talks, if you can leave at least 15 minutes, because there will be a lot of questions.
Yep. All right, so I'd like to start by having you guys help me get my bearings a little bit. I'd like to know what who my audience is. So by a show of hands, who here is an undergrad? All graduate students? Okay, cool. Is there any way, let's see, I think on Zoom you can do raise hand, right?
Yes.
Is it everyone who is a graduate student in the class?
Yeah,
okay. Cool. And then for majors, who here is computer science? Mechanical engineering? And electrical engineering? And then other majors. Okay, cool. And then for the people on Zoom, who, by a show of hands, who's computer science? Okay, and then who's mechanical engineering? And then who's electrical engineering? And then who's other major? Okay, cool. So lots of diversity in majors, and a lot of people from other majors, which is cool. To give you a background on me, I'm Nick Fragale. I'm a founder of a local company called Rover Robotics. I graduated from the U of M in 2014, and I got my major in mechanical engineering. But at the time, I really didn't know what exactly I wanted to do. I knew I was fairly interested in robotics, but at the time there wasn't a huge robotics lab. I predate this building, at least the nice robotics lab part inside of it. So I began my journey at the U of M, kind of figuring out what I wanted to do. And at the time, mechanical engineering had intro to ME, so where you get to build a robot. So I took that course, got into mechanical engineering, but ever since I've been heavily leaning towards computer science and doing programming. So then by a show of hands, who here thinks that they'd eventually be interested in starting a company? Cool, so quite a few of you. And then on a Zoom meeting, by a show of hands, who thinks they'd be interested in starting a company? Wow, lots of people. Cool. So my talk is gonna be worthwhile, I think. So yeah, I think right now is a really good time in history to start a robotics company. There's tons of funding out there, but it takes a lot of work getting from an idea to actually executing on a startup. So I'm going to walk you through my journey, and hopefully that helps you kind of understand what, just from one person's perspective, what it was like, and then hopefully that helps you in the future know what you want to do. So unlike a lot of you guys, I probably wouldn't have raised my hand if I was asked that question when I was in school. My idea after college was I'm going to get a job. I wanted to do controls engineering, maybe something in robotics. And after graduating, there's not a lot of jobs in the Twin Cities for ground robotics, which is what I liked. But there are quite a few jobs in like manufacturing, and you get to program manufacturing arms. So I got a job at a company called Oak River Technology. They got bought by a company called Par Systems. The former is in St. Paul, and the latter is in Shoreview. So both local companies. And I started programming robot arms to manufacture med devices. I quickly learned that programming of an arm is not like programming in the sense that you get taught in school. It's much simpler. You're basically just saying go here, turn on a vacuum, go here, turn off the vacuum, then repeat. It's a very simple form of programming, and it's designed that way on purpose. For manufacturing, you really want high uptime, so you don't want your system to be very complex. So there's not a lot of I would say excitement. So that had me looking for my next thing that I wanted to do. So I worked there for a year, and then I went back to school. I went back to get my master's at Cornell University. I graduated from that with a master's of engineering degree in robotics specifically. And for that degree, it was a lot of what I see in the classes here today at the U of M, where you're focusing more in depth on robotics. That's what I was doing at Cornell back in 2016. And I love that. That's a very exciting space. That's the type of programming that I wanted to do as my career. So again, after graduating from Cornell, I moved back to the Twin Cities. And again, I found the lack of mobile robotics jobs in the area. There was a few companies that I interviewed for, but nothing big, especially compared to like the med device industry, the strong med device industry that we have in the Twin Cities. So I kept looking and I kept looking, and I ended up finding a job at an incubator. It's an incubator out in Wayzata, and the way that I found it is one of my friends from high school. They said they saw that I was struggling to get a robotics job in the area, and so they said, "Oh my God, my dad's working on something robotics related out in Wayzata, something to do with geese." And I was like, "Well, okay, that sounds a little bit weird, but I'll go check it out." And the way that it was pitched to me is that they were working out of some garage and doing robotics. But when I went to interview, I actually found there's a whole incubator, a very nice space similar to this space, all for high-tech robotics and other emerging tech companies. So that incubator is called DigiLabs. It's on Lake Minnetonka in downtown Wayzata. There's a bunch of startups there, and I like to say it's a little slice of Silicon Valley. So there's us, Rover Robotics. There's an e-bike company. There's a VR company. There's an autonomous sailing company. There's a autonomous underwater robotics company, an autonomous underwater, like a second autonomous underwater robotics company that's more like a shape of a submarine. So a lot of high tech stuff. And so immediately when I found that, I was like, okay, cool. I found my home. Something that keeps my interest high. So that was around 2017. And I got hired on there to do a project that was one of the incubator projects. So how an incubator works is there's several startups inside the incubator, and they get resources from the incubator like office space or just help growing as a company. But sometimes incubators hire on staff to actually work as part of the incubator to help out the various companies, or in this case, it was kind of a rare case where the incubator was actually working on an internal project themselves. So this project was to build a robot that chases geese out of people's yards. The founder of the incubator space, he has a home on Lake Minnetonka, and he has a terrible goose problem. So he said, I want to get rid of them, and I want you to do it with neural nets and cameras. And then if you can program a robot to chase geese with neural nets and cameras, then we think of how many applications we can do with that tech. So, so I accepted the job offer, and I started to work on this robot. So at the beginning, it was just me on the project, and I quickly learned how hard it is to build a robot that can go outdoors and train a neural net at the same time. So we quickly hired a second person to take over the neural net side of things, and then I focused on the hardware. So we ended up developing a system that looked like this. This is it deployed out on Lake Minnetonka at one of our early beta sites. This was around 2018. You can see there's a charging dock that has a visual fiducial on it, so that we can program the robot to see that with its cameras. And it has, this one I think had 6 cameras facing all directions, so that you could see that, and then you could autonomously dock. And the original idea was to have the whole system be autonomous. So in the morning, it would wake up when the sun rises, it would pull off the charging dock, and it would start up its cameras and the neural nets to detect the geese. And then once it spots one, it would chase them away autonomously, and then it would return to its sentry location. And then at the end of the day, it would return to the charging dock. So that's kind of the high level state machine. And so I'd say my first mistake as I'd say an early entrepreneur was I came at this problem from a purely engineering standpoint. I was hired on as an engineer to do an engineering task. And now that I've been a CEO for a couple of years now, I've learned that that's the opposite way that you want to come at problems, especially as a business. So if you're getting hired, or if you're starting your own company, you want to do things in a fundamentally different way. You want to solve the business problems first and the tech problems second. And as an engineer, especially an engineer founder of a company, it's very tempting to solve the hard problems. But what you want to do is you want to figure out, okay, what are the easy problems to solve? What's the easiest problem that we can solve in order to get market traction and figure out how to solve the business problems. So for example, in this case, when I started working on this, we developed out the neural nets, like I said. We had a lot of problems with detecting geese far away. So it was easy to write a neural net that would detect a full frame goose. But geese don't come right up to the camera and make it full frame. If they're 100 feet away, the goose is only a tiny portion in the picture. And so at the time, this was 2017, so it was like just SSD and other ways of finding small objects in images were only just coming out, and they were very slow. So you could only run these, like on the hardware at the time, you might only get 1 frame every 10 seconds. So this was the hard problem that attracted us. And it's kind of like a fly to a light. This was the problem that we shouldn't have been solving. But as engineers, we were like, well, how can we make a product if our neural nets can't see geese over 100 feet away? You know, we need to solve that problem to have a viable product. And now, you know, in hindsight, that what we should have been thinking is, how do we figure out if the customer actually wants this product without having to solve that hard problem and spending all that money in order to solve it? So we ended up spending about 2 years developing out the neural net and making the robot rugged enough to survive outside. And then after maybe like a year and a half to 2 years in, we really started to push for beta sites. Our initial idea is, let's get people on the lake to sign up as being beta testers. And then we'll go out and find other markets. We'll see if golf courses want this. We'll see if airports want it. And as part of that, I'd say we learned that there is not a market for this. And we learned that after 2 years. So how we learned that is we went out to airports and we said, okay, airports have problems with geese and you don't want planes hitting geese. So we have a solution. We have a robot that can be autonomous, that can go around the airport, detect geese, and then it'll clear the airport of geese. Well, we quickly learned that airports, although they don't like geese, they like geese on the ground a lot more than they like geese in the air. Geese in the air then hit a plane and then you have a catastrophe. And the first thing that a goose does when you drive a robot at it flies. So terrible idea. So that's something that we could have learned, up front before spending all this effort, but we had other markets. So we weren't in full panic mode. So then we went to golf courses. All right, golf courses have plenty of problems with geese. Surely they're willing to pay, some amount to get rid of them. And there's a lot of golf courses. Surely we can make money in this market. So we went to golf courses. We asked them, from doing research online, we knew that some golf courses use dogs to get rid of geese and some use laser pointers. So we went to some local courses and just asked them, how do those methods work for you? And one thing we found with the dogs is that they often get sick from doing that as their day job. There's a lot of chemicals on the grass of golf courses that make them sick, and the life expectancy of those dogs is about half of what normal dogs is. So I said, perfect. Instead of replacing the dog's job, we're actually helping the dogs, and we're saving them from having this short life expectancy. But then as and that was what our conclusion was before talking to the golf courses. So we went to a bunch of the ritzy golf courses, like surely the really nice ones are the ones who can afford the dogs to come out. But no, that's not what we found. Even the ritziest golf courses, they just use a $500 laser pointer to get rid of the geese, and someone drives around in a golf cart and chases the geese away. And so really we found the willingness to pay in a golf course was, our main competitor was a laser pointer. It's hard to beat the price of a laser pointer when you're talking about a very advanced robot that has to cover an entire golf course. Or multiple systems stationed around the golf course. It really, the value proposition wasn't there. So again, we only learned this years into the development instead of learning that up front. So yeah, I would say find out your market before you do the development. But that comes to another tricky point. So if I were to do it again, would I say, do you go straight to the golf course or the airport and ask them, will you use this? Yes and no. So I think if you go right away, if you have some idea for a robotic application, if you go ask your customer base, will you use this? And you describe the robot to them, because we tried that approach as well. You get a lot of confusion about what it is that you're offering. People have seen robots in movies a lot. Their expectations are very high. And then when you actually show them what the robot does, they are bewildered at how low tech it is. This isn't some highly advanced thing that can cover the entire area. This is only something that can cover a minimal area, and that's something that's hard to tease out in an initial discussion with any customer. So if you can't go to the customer right away and ask them if they need it, and you can't spend the time to develop a couple of years to develop out a solution to see if they want it, and so what is the answer? And that the answer to that we found with one of our customers. So now getting into Rover Robotics. So and I'll come back to the answer to that question after kind of describing Rover Robotics and how and our customer that showed us the better solution and the better approach. So at Rover Robotics, we took the hardware that we developed for this IP67 rated robot, able to be outdoors 24/7, able to monitor things. And we started to sell it online. We thought, there's no market in chasing geese, but surely people want an IP67 rated robot to do various inspection tasks. So we posted it online, put the price online, because another thing that bothered us is a lot of other robot vendors won't tell you their price. So we listed the price, did an e-commerce model, started selling to universities, startups, corporate R&D groups doing research. And we got a lot of people. The thing we found is nobody would click the buy button without calling us first and describing their application. And it was a really good thing for us. We got to hear firsthand what people were working on, what challenges they were trying to solve, what their big ideas for robotics is. And we got a good idea of the space. So we've been selling hardware online ever since 2018. I became the CEO in 2019. I founded the company with a couple partners of mine, Adam Gettings and Eric Zhang. They actually came from a company that called Robotics that developed this robot, and we licensed the IP for it. So that other company, they sold the robot into bomb squad and SWAT team type environments. And when I was doing the goose chasing project, I met up with Adam, the previous founder of that company, and I said, we started using it for the goose chaser product. So when we started Rover Robotics, we had this hardware, but we couldn't sell it. We needed the license to sell it. So he brokered the deal to get the license from Robotics, and that's how we founded the company. And at the time, I was still not thinking, I would be CEO or anything. I was in the early days, I was just the robotics engineer at the company, and there was 4 of us or so. So after a year, my co-founder Adam, he ended up leaving the company. He's an older fellow. He's older. He's in his upper 40s, starting a family. So he wanted to focus on his family. He had already made some money in some other ways. So I took up the position of CEO, which I would say a lesson learned from that experience is that when you go to start a robotics company or any company, it's very important to have the conversation with your co-founders about the future and where you see yourself being at the company in 5 years. We set up the company to be kind of equal founders, and then I found myself alone after 2 years, and it's very hard to change what's called your cap table, or the record of what percentage of the company that you own versus your founders. So over the past couple of years, I've been doing things to fix our cap table to adjust for the fact that I'm now the only founder left at the company. But it's much easier to have those conversations from the get-go. Who's in this for the long term, who's not. And so that's one of my first bits of advice of if you start a company. And the second thing that you want to do when creating your cap table for starting a company is figure out. I lost my train of thought. So the temptation when creating your cap table is to look towards the past and the present when figuring out who gets what. So co-founders will say, some people will put in money and they'll say, my money is really important, so I deserve a big share. And some people will, like in our case, they'll put in IP for a robot and they'll say, that's really important, but that's work that's done in the past. But what's really important to the company is the future. And so you really want to emphasize who's going to be doing what in the future, and how do we make it so that those people are incentivized to stay with the company, to do great work. Because it's very easy if you focus on the past, if then it gets removed from the company, they leave with all their shares, and then you're left with people who are very important for the future of the company, with a lot less shares than they would have if you prioritize things differently. So that's my second piece of advice when you initially create a company, is to focus on the future of the company when splitting things up. And that's a very hard conversation to have, but very worthwhile. So getting back to Rover Robotics, so we sold our hardware on as an e-commerce platform, and we sold to all sorts of companies. And recently, a year ago, we picked up a company that answered the question that I had been asking myself ever since founding the company: is how could I have done the Goose Chaser project differently? How can I advise other startups to solve this problem of skipping the development stage of robotics and really figuring out the business model and if people want your product? And so that customer that answered that question is called Coco Robotics. We met Coco Robotics about a year ago. A couple smart engineers from UCLA who saw the big potential in food delivery. This was peak pandemic time, so DoorDash and Uber Eats and Grubhub were going bonkers. Everyone's ordering food online. But at the same time, you see those companies really struggling. So they're getting huge amounts of revenue in the door, but they're not profitable. And so why aren't they profitable? You have a kind of reuse of the Uber model where you have people driving around the city, and then once an order comes in, they'll go to the restaurant for you. And that's harder to do for food than it is for people. So a couple of the challenges is the high cost of the drivers, and the fact that you're paying them not only to go to the restaurant, but then also to wait at the restaurant while the order is being prepared, and then to drive to the person with their food. And if you think about kind of like what you would pay personally for an Uber to the airport, maybe 20, 30 bucks, but how much are you willing to pay for food delivery? Probably not 20 or 30 bucks. So they had to find a solution, these companies, to solve that problem. If people aren't willing to pay that 20 or 30 bucks for that trip to happen, how do we make money? So the answer that those companies found is, well, let's charge on both sides. We'll charge the customer, we'll charge them $8 for the delivery, and then we'll charge the restaurant as well. So each of those companies, they charge 20 or 30% to the restaurant. So if you order $50 of food, that equates to maybe $10, $15 being charged to the restaurant for the delivery, and then $8. So all of a sudden you have a $22 per trip, and that covers the cost, or at least it comes close to covering the cost. So these companies are still not profitable, largely because of the rising cost of labor in the country. There's a lot of pushback on the drivers for getting better wages and being considered fully employees instead of just contractors. So now you're having to consider healthcare costs and all that. So enter Coco Robotics a year ago, trying to solve some of these problems. So their idea is, let's put the food in a robot and deliver it. It wasn't a novel idea, but they had a different approach that's allowed them to scale much quicker than their competitors. So the idea behind a robot doing this task is when an order comes in, these robots are already stationed at the restaurant, so they get dispatched immediately when the food is put in. And so there's no waiting. There's not a person waiting around for the food to become ready. And when the order comes in, the person doesn't have to physically drive to the restaurant. So you cut out 2 steps of the delivery, and you just have to get the food from the restaurant to the person. So you save cost that way. And then obviously a robot traveling down the sidewalk is not as fast as a car. So you just cap the delivery radius at 2 miles. And you say any order that's come in within a 2-mile delivery radius that goes out in a robot, anything further than that is from a driver in a car. So here again, you have a very hard challenge of, like our Goose Chaser project, you have the hard challenge of how do we make these robots go from the restaurant to the end user. And so if you're taking the engineering approach, like we did back on for the Goose Chaser product. You might say, okay, how, let's stick cameras on this, let's stick LiDAR, let's stick all the things on it to make for a good robot that can localize in an environment, that can stay away from everybody. And if you did that in a company, and companies have done that, Starship Robotics is a prime example. They're the incumbent in the industry. What you get is very slow growth. You have to make sure your autonomy is really reliable, so that it's when it's looking at a street crossing, it's not getting it wrong and crossing at the wrong time and getting hit by a car. So what did they do? Instead of solving the hard problem, they found an easier problem to solve that acts as a stepping stone. They put 4G cell modems on the robots and cameras, and they have people driving them. And that's the solution to bridging the gap between whether people want your service and developing out the whole thing, is doing something that for an engineer might seem kind of embarrassing. Like you're saying, I'm just gonna ignore autonomy and I'm going to put a 4G modem on this thing and people are just going to drive it. And it's been an overwhelming success for them. In the past year, they've gone from the prototype unit to 150 robots on the street. So this, to give you an idea, the two incumbents who are in the industry before them, Starship and Kiwi, took about 5 years to do the same task, getting 150 robots out there. And that's because they were focused on autonomy. How do we make these things reliable enough so that we can actually stick these things out into the world? And they didn't take that approach of remote operation first. So that was eye-opening to me. How, like, the amount of scale that you can reach if you can just take your engineering hat off for a second and say, okay, how do we attack this from a business standpoint, and how do we solve the easier problems, and then know, eventually this will be autonomous. And I'll admit, I did have this idea for the Goose Chaser. Eventually we did end up making it so that you could remote in over a CellG modem. And I can tell you, if you sometimes you're able to take your engineering kind of hat like halfway off, and you say to your investors, I think we should do remote operation. And then there's some pushback. What about the profit margins? What about, we need a plan for autonomy. And when I was faced with that, I said, yeah, you're right. And I put my engineering hat back on. We'll focus on both. We'll focus on remote operation, and we'll also be working on autonomy. And what that does is it splits your team. You now only have half the resources to work on autonomy and half the resources. And so really the lesson that I learned from Coco is they took their engineering hat off and they threw it as far away as they could and said, no, we're only focusing on remote operation. Our whole team is going to be focused on that one goal. And what that does is everyone in your company is now striving for one goal. And it's surprisingly hard to get a company to strive towards two different goals at the same time. So that works wonders for keeping everyone on the same page. So here's a video of one of those robots in operation. This is in May of this year. So this is how these robots work. So this is someone remotely driving this robot down the sidewalk. And once it arrives, you get a notification on your phone. You hit the unlock button. It unlocks its lid. You pull out the food. You hit on the app that you've received the food, and someone drives it back. Pretty simple. So yeah. So yeah, I would say that's my biggest advice to all of you that are interested in starting a robotics company is once you've thought of an idea of what to do, try to figure out the simplest way of getting that out into the world and getting real user feedback. Not just talking to someone, but actually showing them, here's what the robot is going to do, and doing it in a mechanical Turk fashion. So lastly, I want to talk about one of our interns from a previous year who worked for us 2 years ago, and he also started his own company. His name is Jack Killian, and he started a company called Poultry Patrol, and they do these robots to monitor turkey barns. So the idea is, okay, each day, if you have a turkey barn like this, you have some amount of the turkeys that die. If there's 10,000 turkeys in a barn, it's pretty easy to calculate. It's usually 1 or 2. And so when they die, you want to get them out quickly. So someone's chore on the farm is to sweep up and down the rows of turkeys to find these mortalities. And so it's become increasingly hard, especially in the Midwest, to find people at a wage that the farmer can afford in order to do this chore. So the idea of Poultry Patrol is to have a robot do the same thing. And so you have a mechanism here that can go pick up, it can recognize a bird with the cameras, it can drive up to it, and then it can open its tines and pick up the mortality and move it to the side of the barn, saving about an hour or 2 of chores a day for the farm. So yeah, so that's it. Now we're kind of caught up to present time. I'm currently, our team is currently 5 people. We're a rather small team. My last bit of advice towards you as you think about your ideas of what to do with robotics is Rover Robotics is a hardware supplier, and it's hard to make money in hardware. What they say about it is true. We've definitely found that. So as you're thinking about your ideas, the big thing in robotics right now is finding other business models to make money off of hardware. The most common one is called robot as a service. So what this looks like is instead of charging the customer one time for the robot, and then it's now their problem to fix the robot, to operate the robot, what you do is you become a full service company. So a perfect example is security robots. So a lot of companies need security out there, but if you're some company that needs security and you're interested in a robot, you probably don't want to fix the robot if it's broken. You don't want to monitor the robot. You just want a security guard to happen without you thinking about it. So the robot as a service model says, okay, as a company, you charge the company, your customer per month, whatever rate that you decide. So there's for example, there's a couple companies that are doing this in the security space. They charge $8 per hour for the robot, which is a pretty digestible thing if you're considering replacing like a security guard with a robot. They've chosen $8 an hour for a reason, because companies in markets that the minimum wage is going up to $15 an hour, this is a way of keeping a rate of $8 an hour. But in actuality, if you times out $8 an hour for the whole year, you're being charged $16,000 per year that you're making off of this robot, and that's a lot more digestible for a company than saying from the get-go, hey, do you want to pay $16,000 for this robot? And then you become a full service provider. And that's I'd say a much better business model. So if there's any applications that lend themselves specifically to robot as a service, those are going to be much better ones to start up a company and sustain a large growing team of engineers. So yeah, that's all I had for the talk. We can start the questions now.
Thank you.
What's the vision for Rover going forward? Do you plan to iterate on design for new features or maybe optimize it? Yes, that's a very good question. So right now, I guess one thing that I didn't get to in my talk is that when you raise money for a startup, you have to go to investors to raise money. And there's two main types of investors. There's angel investors and there's VC investors. Those are the two. There's other types, but those are the two major categories. So in the local market here in Minneapolis, there's a good amount of angel investment, and there's some VC investment, but I'd say a majority of it goes into the health sector. And so for robotics investment, most of the money comes from California. So for us in particular, when we look at possible investments, we've in the past raised money from local angels who are okay with doing hardware. And so that's kind of our company vision going forward, is sticking to what we're good at, sticking to hardware, and being very good at that, continuing to iterate on our designs, mainly because you have two choices as a startup. You can either tap the local angels, you go out and find ones that like hardware, or you can go to a bigger market like California or Boston and raise money from those. But the thing that you'll find going to those markets is they'll always look for the robot as a service models. They'll look for the other type of the business models that can make more money than just selling hardware alone. So hope that answers this question.
Thanks for
Other questions?
Yeah.
when you say going into different markets, what does that look like? You physically go there, or just getting in contact with people that network?
Very good question. And the answer is different for a time of pandemic than non-pandemic. So yeah, I'd say the VC investors, they historically have been hyper-focused on regions. So for instance, a lot of VC groups, they won't invest in you unless they can attend board meetings in person. So if you're not within driving distance of their house and their lifestyle, then they won't invest in you. And that's not all VC groups, but it's a lot of them. So traveling, if you want to base a company in Minnesota, you either have to travel to California a lot and talk to groups and just hope that you find one that is willing to invest outside of the region, or you find money locally. Yeah, but yeah, to answer your question, I've traveled to California a lot in the past 3 years. Whenever you can, an in-person meeting's a lot better to try to convince someone to give you money than a Zoom call. But sometimes a Zoom call's all that you can get because there's a pandemic.
It's my time.
Yeah, there's no other questions.
Yeah.
So this Coco Robotics that you just showed, you said that something was driving the.
Yep.
You also mentioned that companies like Uber for the food delivery model was profitable because I'm assuming because a lot of the salary goes to the drivers and as well.
Yep.
Even if somebody's driving the robots, how does that exactly happen? It's essentially the driver does, right?
So what was the last part?
So even for the Coco Robotics, the robot is being driven by
Yep.
the driver. So even that person must be like getting salary and also how exactly is it like how does the business model work?
Exactly. Yep. So the business model works in two ways. So it works by burning a lot of cash in the interim while you try to gain a market, and you get as many robots out there and get as many users onto your app. And one thing that, especially in the current climate, it depends on the mood of investors. But right now, companies are growing at a really fast rate, and so investors are really prone to doing models where you worry about revenue instead of profit. So for instance, DoorDash, while it was growing, was unprofitable the whole time that it was a startup. And they even IPO'd while they were not profitable. So from an investor standpoint, if you're going and raising from one of the big groups, money from the big groups, they'll say, don't worry about burning a bunch of money. As long as you can get that revenue number up and up and up, we'll find subsequent rounds of money to come in and fund the company going forward. Then the other thing that saves them from burning too much cash is the fact that when what I said before, when an order comes in, they only have to drive the robot from the restaurant to the customer instead of driving from some random location to the restaurant and then to the customer. So they're saving about 40% of the time of the people. And then once the person's driven back to the restaurant, then they immediately they remote into the next robot. So they're essentially teleporting, if you were to think of them like a real person or a physical person. So that saves them about 40% of the cost of all their employees who are driving these. So when they go to a restaurant and they say, work with us instead of DoorDash or whoever, they say, we'll cut the cost of delivery by 20% or 40%, the same amount like that they cut in costs on their side. They pass some on to the customer in order to grow the company. Yeah.
Looks like Shuhan has a question. Lots of schools have robotics programs where you collaborate and bring it in syllabus and explore this.
Collaborate and what?
It just says collaborate and bring it in syllabus.
No, I haven't heard of that, but I'd be interested in learning more. Yeah. Yep.
So what's your focus on the autonomous robots going forward? What are you talking about? What's your plan for this aspect?
Yep. So Rover Robotics focuses on the hardware aspects of things so that other people can focus on the software. So in the case of Coco Robotics, we provide them the rugged hardware that is used to make the delivery, and then we leave the vast majority of the software up to them. So for instance, we create the ROS driver, and then they program the whole rest of the stack, which is right now hooking up to a web portal so you send the video back, and it's just a simple H.264 video client right now before they focus on autonomy. But yeah, so as part of that, you also we work with them to make sure that the hardware is future proof. So you stick the hardware in the robot to make it eventually autonomous over software updates. And we call this the Tesla approach. Like the Tesla Model S's and the Model 3s have all the hardware needed to become fully autonomous eventually with software updates. So companies like NVIDIA have made this very easy to do with creating modules that you can then swap in and out. And then so if you build the NVIDIA computer into the product from the get-go, then that's what you're going to need eventually to make it autonomous. Yeah.
For that, you can essentially create like an all-terrain autonomous vehicle, right? So why don't you try to break into the space industry? Yeah.
Yeah. So I would say we created like a fairly all-terrain robot that was autonomous like 10% of the time. Or like much less autonomous than you'd want it for most applications. Like, so really taking that tech to another industry, it's really hard to take like all the code needed to make something autonomous and transfer it to a different environment, because most of the time you're using sensors that are optimized for that specific environment, and you've tuned them for that environment, and so it's hard to transplant them. Yeah. Yeah.
You made this very good distinction between, splitting your company focus into different parts, one would be the going to be implemented autonomous.
Yep.
So from like a business perspective, in the future, you did have to go autonomous. Would you spin up a separate company, or how would you handle
Yeah. Yeah, that's a good question. So kind of like as an upper management or CEO, by focusing on teleop first, you can really make sure that your focus is on that while you're putting out all the fires, which is going to be things with operations, how you communicate with customers, how you what you do when something breaks down, and hopefully in like 1 to 2 years, if your focus is on that, you've solved most of those problems, and you've also collected a large data set. So then after 1 or 2 years, you can spin up a team, an autonomy team, and you have the data set, and you've already put out the fires on the other part of the company. So you are safe to switch your focus without sacrificing that operations team. Yeah, good question.
And then just one more from Sharon again. If you don't mind me asking, what is the price of this robot?
Yeah, so all of our prices are listed online. So for we have 2 models. We have the Rover Pro, which sells for $8,000, and we have the Rover Zero that sells for $3,000. The 2 models are exactly identical in size and form factor. The Rover Pro is the one that I was talking about. That's fully waterproof. You can even drive it into water and out of water, and it'll be fine, which is cool, but it's overkill for most applications. So we stripped out the water water seals, and we stripped out the active cooling inside that's needed once you seal something, because you also seal in the heat. So we stripped all that out, and we made the Rover Zero, as zero meaning kind of like a stripped down form of the Rover Pro. And yeah, that saved us a lot of costs, so that we're able to offer it at a much lower price point of $3,000. Yeah. When we sell a robot, there's only wheel encoders as the sensors, and then we sell R&D payloads, we call them, with various sensors that you can use, like the Intel RealSense, RP lidars, different stereo cameras, and lidars mainly. On these robots, for food delivery, there's stereo cameras. They used to have a lidar, but they get rid of that. Our customers all put various sensors on the robot. So we sell a platform that's expandable, and then people add to that as needed. Yep. Yeah, you get access to a normal computer running Linux. So you can plug in whatever sensors you want that are USB, Ethernet. Yeah.
What would be the initial capital needed for a startup?
Yeah, so that's another good question. So capital, when you're thinking about doing a startup, for us, for our first round, we raised $500,000, and that was enough to get the website launched. It was enough to hire a few people to handle the different aspects of the business. That's what it takes to launch a hardware business. We also use a platform called Shopify, which allows you to spin up a website very easily and have an e-commerce model. They take care of all the payment processing and stuff like that. For a different type of robotics company, it's a completely different story. You can start up a company with just like under $5,000. Like if you just purchase the hardware and start doing something, then you can go to a program like Techstars, or there's other incubators that do regular events where you do a demo for them, or you give them a pitch. And if you're already to the point of having hardware and demoing something, you're at a good point for that, and you can raise $250,000 to $500,000 to grow your team a little bit, and And then after that stage, you're probably looking at and some VC groups to do what's called a seed round, and those might be $1 to $2 million, and then after that, you do a Series A that might be $5 to $20 million. That's kind of the regular path that companies take. Yep. Yeah.
So throughout your journey of setting up your own company, did you have a hard time dealing with uncertainty or self-doubt?
Definitely, yeah. And if you, I read a lot of books of other CEOs, and always it's a lot of doubting whether the thing's going to work out, whether you're the right person to do it. I think for the most part, it's a lot of perspiration that ends up being why people succeed. Just sticking with it long enough for it to succeed. Yeah, you can't catch a wave unless you're in the water. So, and I don't think anyone out there has enough confidence to say, I know without a doubt that I'm not going to fail. So,
How do you deal with all this?
yeah, I personally maintain, like, I'd say, a very good work-life balance compared to other CEOs, just to keep the stress in check and make sure that I'm not burning out. I don't know about other CEOs. Everyone seems to have a different way of dealing with it, but I think one of the keys to success is figuring out for you personally what the best way of dealing with the high stress and uncertainty is, and persevering. Yeah.
One question. So, let me ask you questions. So, if you would have had to repeat this journey, you were starting from, what do you have changed, if any? You have made any changes?
Yeah.
And this leads to my second question, which is very common. I want these kids to understand it. How do you control your company? Really? Anytime that you bring money, I want you to understand
Yeah.
that you are losing a big part of the company, which means basically, as long as you are, correct me if I'm wrong, as long as you are as long as you are above 50 plus 1 vote, it's okay. 50 and down, it's very tough. So I just lump them together, but
Yeah. Yep.
I want them to think about this.
Yeah, it's hard from from a very young founder's perspective to figure out those things, because you're not only having to figure out like the day-to-day of the company and like what you do and your product, but you're also having to step away from like your day-to-day role and thinking about company things, like how do I maintain control of the company? How do I raise the next round? How do I do all these things that don't really go towards selling a product, but I need to do personally to remain viable as a company and make sure that we're on the right path. So to answer your first question, what I would do differently for Rover Robotics, I would say the first and foremost one would be I would try to solve business problems before solving engineering problems. Like maybe if before even starting Rover Robotics, if I had taken that approach on the Goose Chaser, then I'd have had enough time to try another application. But instead, I spent 2 years on the Goose Chaser project only to figure out, this isn't a viable business market. So if you find yourself in an opportunity where you're able to iterate fast, like inside of an incubator, which are pretty common nowadays, then I'd say listen to the advice of iterating fast, and they say fail fast, and that's a way of failing fast. So I guess that's what I would do differently. And then how you maintain control of your company, I would say think about have those tough conversations with your founders so that when they leave, and if they leave, that a large amount of shares is not also walking out the door with them. because that's a fast way of kind of losing control of your company. Another way is making sure you find the right investor for you. So finding an investor is more like it can feel like, from a founder standpoint, like you pitch to like 100 different investors and you get a lot of no's. It starts to really feel like I'm just going to say yes to the first person who says yes to me. Like, it's very tempting because you've put a lot of time and effort into these, and once you get an offer on an investment, it's very enticing. But you need to think about it more like how people think about dating, or finding a lifetime partner. You are finding a partner for your business, and if that partner is not aligned with your goals, it's going to be a terrible ride, and you should not take money from them. If they don't completely agree on your approach, or more like if they don't fit your personality type, that's probably the most important thing. Is are you comfortable just sitting in a room with your investor, or are you like sweating bullets until like they say the next thing, and then you just don't work out personality wise? That's a very bad recipe to get things started off on. So find the right investor, and then once you find the right investor, you can have an honest conversation, and a good conversation about how to split up the company, how much shares they deserve for putting money in. And once you find that in an investor like that, the conversation then becomes easy. They value you as a person, they value your approach that you're taking, and it becomes much easier to maintain control of your company. Yeah.
The future you see your vision, like, let's say when you start, you have a vision of what I want to do, like, or what would it. How do you decide on that time span? How far should I take it when you start?
Yeah, that's another very good question. So the thing that I didn't consider when starting Rover Robotics is that some companies are, I'd say, applications focused, where like the delivery application. So you're doing one thing, and that's delivering food. And so when you bring the whole company into a meeting and you're trying to strive towards that goal, it becomes very easy to set different KPIs, they call them, key performance indicators. So how many deliveries are we doing per day? And if we're doing less than 10, we got to do more to get up to that goal, or whatever it is. And so as a startup, you want to do goal setting on a monthly basis. Large companies act on a quarterly basis. As a startup, you want to do what can we achieve in the next month? And then when you talk to investors, you're talking 1 year out, you're talking 5 years out, longer time periods, and you're of what you will accomplish. But then in the day-to-day, you're setting those monthly goals. So one of the hard things I found at Rover Robotics is, since we sell hardware, you can do anything with our hardware. You can stick whatever sensors you want on them. And we're a hardware platform. We're not an application. So it becomes very hard for us to set KPIs. We can say, okay, we think if we allow customers to use more sensors, that we might sell more robots. But it's hard to set a KPI of just sell more robots. For that, you'd have a sales team. And a sales team doesn't work very well in our industry, because you'd have to have a very knowledgeable sales team. And engineers usually don't like moving into sales. So it makes it very, very difficult. So yeah, I hope that answered your question.
Okay, thank you very much for an excellent.
Thanks, everyone.
We all appreciate it.
Cool. Very jealous of the colloquium in general. It's not something that existed when I was in school here, and I could have very much benefited from it. So
Hopefully you absorb.
all right.
Okay,